1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Oh, lights. Lights, my goodness. Good evening. This is VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. 121212. Now, for some reason, we don't have audio on 80 meters. Why is that? 1 2 3 4 5 1 2 3 4 5 VK. Oh, hang on, there we are. 1 2 1 2 1 2 1 2. Something at the back here. Hello test, hello test, hello test. Hello test, hello test, hello test. Stand by tick while we work this out. Stand by. Hello, hello, 1 2 1 2. Now we've lost audio on both. This is a test transmission at the moment. Hang on a sec. Why have we lost audio? Hello, hello, hello. Now there was plenty of audio there. 1 2 1 2 1 2 1 2 1 2 1 2. Hello test. Yes, technical difficulties right at the start, and that's strange. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 4 5 4 5 4 5. Why? Hello. There we go. Hello. 1 2 3 4 5. All right. 1 2 3 4 5. 1 2 3 4 5. That's touchy. Hello. 1 2 3 4 5. 1 2 1 2 3 4 5. I don't know if that's working properly. Alright, good evening everyone. This is VK3EKH, and I just need a report on both HF frequencies. If somebody could just give me a quick... Which band? Oh, really? There seems to be plenty of audio there. Oh yeah, I think that part of it's probably okay, but I can see plenty of modulation on both HF. 1 2 3 1 2 3. Why is it doing that? Hello, 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. Okay, we've got. I'm running AM on 160 tonight, and 80 meters. There should be.
Yeah, 160 good. 80 is audible now, but it's quiet.
Yeah, hang on. Hello, 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 hello. 1 2. What is it about that one? Hello, hello. Hello, hello, 1 2. What is it about that? One, two, three. I just tested this just a short moment ago, and I'm sure it was all okay. 1 2 3. Yeah, when it goes to, when I start to do the program, one, 1 2 1 2 1 2. Why is it doing that? That's no good. One, two, three, four, five. EK3 EKH testing on 1865, and just trying to work out how come we've lost transmission on 80 meters. Yeah, that's interesting. Oh, good, great. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. Alright, standby stations for this. We'll get there in just a moment. We apologise for this break in transmission. We shall resume as soon as possible. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Why is it doing that? Why? Check 1, 2. Check 1, 2. Wouldn't
That's definitely better.
just try and experiment here for a tick. Wow. One, two, three, four, five. Oh dear. 1, 2, 3, 4, 5.
He's probably not monitoring these frequencies, although I think I can hear feedback, so he might be.
1, 2, 3, 4, 5. Yeah, I don't know what's going on. Worked perfectly well at KB4. One, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Harlow. 1, 2. 1, 2, 3, 4, 5. 4, 5. 4, 5. Wouldn't it bother you? Alright, I think 160 is okay, because that's what I'm monitoring on, 160.
Yeah, 80 seems to be coming through okay now.
Okay, so I'll go to monitor 160. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, I think it might have been just a case of RF getting into things. 4, 5, 4, 5, 4, 5. 1, 2, 3, 4, 5. VK3 EKH testing, just technical difficulties right at the start there, and I think I've got something happening on 80 meters now. Richard, what do you reckon? Does that sound all right?
Yeah, it sounds six better now.
Yep. Okay. Wouldn't it bother you? All right. Yes. You know, I did all the tests prior. You know, and there it is. So I'm transmitting AM tonight on 160. It's about 100 watts on 160. It just sounded so much better in the headphones. I'm just running normal transmitter tonight on 80 meters. So I'm hopefully I'll be heard okay. Anyways, we're also broadcasting via the Melbourne television repeater, VK3RTV, digital channel 1. I don't know if that can be seen on the BATC site. I don't know whether that feed is working tonight. Also you'll find the HD transmission on my YouTube channel. So by typing in VK3CSJ, you should be able to find the YouTube link, and that's a high definition stream, providing that Big Pond or Telstra is putting me through. And we're also audio streaming tonight for the first time. I think it's the first time. 1, 2, 3, 4, 5. Yep, there I am. So we've brought back the audio stream tonight in glorious hi-fi. So if you want to detect the audio stream, Firefox is probably the best browser. So if you've got Firefox on the system, by all means use Firefox. It works straight away. But if you use Chrome, you'll have to click on the little link in the audio stream, right-click it, and that'll open up a new window to listen to the audio. For some reason, Chrome browsers aren't working properly, and but by right clicking on the little play icon in the audio stream on the ASV website, that'll open up, or you'll get the option to open up another window, and that will actually play the audio stream. But like I say, if you've got Firefox, Firefox is doing the right thing and just playing the stuff. So I've been on a couple of technical gyros that are looking into the situation, but it is working. The audio stream is working. I can see that. And I think we also have a email address. So if you want to send signal reports off tonight, you'll by writing an email to vk3ekh@gmail.com, vk3ekh@gmail.com, and I'm looking at the inbox as we speak, and I can see there's already a couple of emails there from Andrew and Andrew. So g'day Andrew, and just checking in and checking in take two. So he's probably giving me a report there on the stuff up at the beginning of this transmission today. Unbelievable. Yeah, it's all to do with the audio stream. I've been trying to get the audio stream to function, and I've been having all sorts of hassles getting things sorted out. For those watching the TV side of it, you might have noticed the intro, the new intro, ASV Intro, which is done by Lee Green. Thanks, Lee, for compiling that and allowing me to use that use that as the intro now to the ASV broadcast. The sound should have gone across to 80 and 160. That's what threw me. I'm thinking, why can't I see the sound coming through on 80 and 160? So I'm sure I had that all checked and working, and I was pleased with the way things were working. But there it is. You come up to the hour, right 10 o'clock on the noggin, and the bloody thing doesn't want to work for you straight away. So unbelievable. That's the nature of the business, isn't it? Anyways, all right, we have a few little articles tonight, and there's some imagery associated with them. So again, if you want to catch up with the vision side of these little pictures and images and whatnot, just tune into the YouTube stream where it's HD, and also, of course, for the folks on Melbourne TV repeated, no worries at all. Okay. Martin VK7JH is saying, okay, I'm hearing you now. G'day to Nebs, Cassiopeia, welcome tonight. And Martin's reporting that it's a beautiful sky down in Tasmania, so I can just imagine how clear the air would be down in Tassie. Alright, you're tuned to ASV Radio, VK3EKH. We're starting about 10 minutes late tonight, so I really do apologise for that. A very pleasant good evening to anybody up at the Messier Star Party. Officially the Messier Star Party kicks off tomorrow afternoon for up there at the Dark Sky site. And I know that Phil is up there, and I think Steve is heading up that way. So g'day to whoever's up there at the moment listening on the receivers, either in the club room or in the lab, I don't know. But again, send us an email, vk3ekh@gmail.com, if you're near the internet, have internet access. Actually, I'm going to take these headphones off because it is a bit of a nuisance factor to be hearing myself directly in my head. It's bad enough that I hear myself in my head all the time. I don't need to be forced it. So I shall just throw those there. Make sure the hair's right. And good evening to everybody who's watching. Yes, fine. Alright, now for the usual blurb. And I think I'm all okay. And again, I'm transmitting AM. I'm transmitting amplitude modulation on 160 tonight, on 1865. So for a lot of local lads, I should be producing a fairly decent signal, actually. Although you can still resolve the AM signal on sideband if you're having difficulties. But AM should be a nice PHY signal from what I can hear. The Astronomical Society of Victoria, founded in 1922, comprises well over 1,600 members throughout Victoria and the other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. in the Mulia Hall, National Herbarium, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in the... I've already mentioned that. No, I didn't. Marking, yes, including marking. Parking is available in Burwood Avenue, Dallas Brooks Drive, and within the surrounding areas. Admission is free and visitors are most welcome indeed. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory. Receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and there's also lingering a photoheliograph around the place. The Society has also a number of 200mm reflectors available for a short period of loan to members so that they can try before they buy a concept. Regular Society Club Night meetings are held on the first and last Fridays of each month at the Lodge, the Society property in Burwood. Members are... Oh, wasn't there a meeting this week? Damn, I was going to sit in on that. I completely forgot. Anyway, that's another story. That was another story. I completely got distracted there for a moment. Members are also encouraged to make use of the Society's country property located in Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, and ranging from 300mm to 1000mm aperture. Also located on the site is an 8-metre radio steerable telescope, that is to say an 8.5-metre radio telescope, fully steerable, which members can access with involvement through the radio astronomy section. Meetings, members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest and members that can participate include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology, astrophysics, historical studies and research and astronomy in general. Contact details for the ASV website, that is to say contact details for various section directors, are provided in the yearbook. Further information can be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra bulletins sent out via email to members. Please note that the ASV will conform to all the government health directives. ASV events may be required to be cancelled, moved or postponed. Any information from the ASV can be gleaned from the Secretary by writing to the Secretary, that is the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. But, however, we do have a useful website that is for more and further information. I'm not with it. www.asv.org.au. That is www.asv.org.au. And it is streaming. Oh, good. Thanks, Simon. Get it. Welcome, Simon. You're viewing on a night that things are falling apart around me. Yeah. Anyway, I'm hoping things have settled down a bit. I haven't had my cup of coffee yet either. All right. So we have Richard VK3VRS, who's also joined the chat window. If you want to come up on the chat window, Discord, go to the ASV website. When you go to the ASV website, go across to where it says Radio Astronomy, click on that. That little drop box that opens up. Down at the bottom is a link to the ASV Radio broadcast. And when that page opens up, you'll see not only the YouTube stream, but you'll see the audio sound stream there as well. And just below that is the little square box. It's got a radio telescope in it, and that's the link to Discord. And you can just go to that, and it'll put you right through to the chat window, and you can chat while I'm talking. So anyway, there's a few folks there on the chat window. Come on, Tony, get on there now. Also, now just checking the reports. Don has also sent in a report right now, and he says on email, this is vk3ekh@gmail.com. Great signal as usual tonight. 20 over 9, 80, and 10 over 9 on 160. That's good. AM sounds great. Yeah, that's what I thought too. That's why I'm running it. It's much fire than it is on the SSB. All right, so there it is. See you all next week. No, I love doing that. Okay, let's kick off the the next report here. I have no reports from spaceweather.com. Unfortunately, no updates there. Okay, all right. The first article for tonight is courtesy of www.physicsastronomy.com, physics-astronomy.com, and the article is titled "The Dark Forest Theory Explains Why We Haven't Found Aliens Yet, and It Is Pretty Terrifying." Now, I've got a little image here to bring up on the TV, so let me just bring in that. Oops, that's the stream. Done with the stream. Back to vMix, and I'll bring up the image. Where's my camera? Make sure the camera's there. All right, just stand by, and we'll go to this little funny-looking image that's associated with the article. All right. Now, I think everything else is working there. Alright. The Milky Way Galaxy is made up of 200 billion stars and maybe 100 billion planets. Even if just a tiny proportion of those planets maintained life, and even if only a pitiful scattering of those planets had intelligent life forms, our galaxy would be swarming with alien civilizations, some of which would be seeking for us or discoverable for at least a short time. The Drake equation, which converts the preceding components into variables, may be used to calculate the number of terrestrial civilizations that should exist in the galaxy. When you enter them into the calculation, you get to the conclusion that our galactic neighborhood should have at least 20 civilizations. When you think about it, the fact that we have yet to discover any other life in the universe is almost outstanding. The Fermi Paradox, F-E-R-M-I, the Fermi Paradox refers to the apparent discrepancy between how many advanced civilizations there should be in space and the lack of evidence of any. Over the previous several decades, it has given rise to hundreds of concepts and proposed solutions. The dark forest theory explains why we haven't heard from aliens by asserting that they are intentionally staying quiet. The argument is best spelled out in Lou Cixin's book, Cixin's book, The Dark Forest, titled The Dark Forest. The storyline of the book, the second in a trilogy, is concerned with how to communicate with possibly hostile extraterrestrial species. The following is how the novel argument is set out. All life seeks to stay alive. I won't go political at the moment. Sorry. All life seeks to stay alive. There is no way of knowing if other life forms can or will annihilate you if given the opportunity. In the absence of guarantees, the safest choice for any species is to eliminate other life forms before they can do the same. Because all other life forms in the book are risk adverse and prepared to go to any length to preserve themselves, every contact is risky, as it nearly always results in the contact species wiping out whoever was dumb enough to give away their position. As a result, all civilizations seek to remain radio silent. This excerpt from the book explains the reasons for the paranoia. The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without sound. Even breathing is done with care. The hunter has to be careful because everywhere in the forest are stealthy hunters like him. If he finds another life, another hunter, angel or a demon, a delicate infant to a tottering old man, a fairy or demigod, there's only one thing he can do: open fire and eliminate him. Scientists David Brin proposed this notion as a possible answer to the absence of radio evidence of extraterrestrial life. While the form he describes employs robotic probes to eliminate civilizations other than the one that produced it, essential principle remains the same. In this paragraph, he argues why the answer is appealing from a technical standpoint but horrifying from an existential one. It is consistent with all of the facts and philosophical principles described in the first part of this article. There is no need to struggle to suppress the elements of the Drake equation in order to explain the Great Silence, nor need we suggest that no ETIS anywhere would bear the cost of interstellar travel. It need only happen once for the results of this scenario to become the equilibrium condition in the galaxy. We would not have detected extraterrestrial radio traffic, nor would any ETIS have any settled on Earth, because all were killed shortly after discovering radio. For over a century, we have been shouting our existence to the universe. Any extraterrestrial within 100 light years of us would be bombarded with radio transmissions from our way. We should have a problem if we had reason to avoid informing aliens about ourselves, as Stephen Hawking believed we do. There it is, short and sweet, and I'll just go back to the camera. I'll keep opening up the stream box. Oh, thank you. I did have that there. There it is. Okay, back to the camera. Camera. Oh, there it is. Okay, vMix. Got to get used to vMix. Cheers. Oh, I love that ouzo. All right. You're tuned to ASV Radio VK3EKH, broadcasting on 1865 and 3541 in the 160 and 80 meter amateur radio bands. That's my super announcing voice. Okay, now now you'll find that if you want to read that article for yourself, you can find that. I'll just bring it back up. Yes, it was www.physics-astronomy.com. That's the website, physics-astronomy.com. And there's lots of stuff there, and I just picked up this one. The Dark Forest Theory explains why we haven't found aliens yet, and it is pretty terrifying. And of course, we have been sending out radio transmissions, not deliberately into space, they just as a result. But I think the only transmissions of merit that would be heard anywhere from this planet are radar emissions, which really doesn't carry much intelligence, and deliberately beamed transmissions into space, which has only been done a couple of times. But most of terrestrial transmissions, such as broadcasts and TV transmissions, are all aimed at terrestrial. It's not aimed up into space. So whatever residue of RF emits off into space, it wouldn't travel that far before it fades into noise. So you know, you'd need another planet, you know, 4 light years away. If there was a planet 4 light years away, they would have to have a telescope similar to the old radio Arecibo telescope with very good sensitivity to have a chance of detecting anything from us amongst the noise. There might be something there, but like I say, radar, you know, beamed radar transmissions, radar. It's all aimed at the horizon mostly, so that zips off into space pretty well. Enough of that. All right, this is VK3EKH. Okay, this article, how long does this go for? It's got a few images in it. It's pretty short. It's just full of pictures. All right, I'm going to bring up an image, and this is right. Now, what you're seeing on the screen there, and YouTube, if you're watching YouTube, go back to the article. What you're seeing there is a neutron star. A neutron star is the densest objects astronomers can observe directly, crushing 500,000 times Earth's mass into a sphere about 12 miles across. This illustration compares the size of a neutron star to the area around Boston. Well, if you're all familiar with Boston, that image you're seeing there is what the size of a neutron star, crushing 500,000 Earths into a little area, a sphere about 12 miles across, using miles. All right, the article it's titled, courtesy of Sky and Telescope, Pulsar shoots 7 light-year long phaser blast. Nature provides truth is still stranger than fiction. A pulsar has shot energetic particles in a thin, straight line that extends for light years into space. The discovery might explain how antimatter makes its way to Earth. Star Trek can keep its ray guns. Pulsars make far more powerful beams of radiation. Crushed stellar cores left behind when a massive star goes supernova are among nature's own particle accelerators. Though pulsars are only the size of Manhattan, their dizzying spins and powerful magnetic fields can energize particles to a significant fraction of the light speed. In addition, pulsars glow with high energy radiation, which can itself convert into pairs of electrons and their antimatter counterpart, positrons. That's why astronomers often point to pulsars as a primary source of the antimatter detected at Earth. For example, the Alpha Magnetic Spectrometer aboard the International Space Station has detected a surprising amount of positrons. But the same magnetic fields responsible for accelerating particles also act to cage them. So some have suggested the excess AMS found may be a signal not from pulsars, but from dark matter. However, one pulsar shows a possible remains for particles to escape their confines. Okay, I've got another picture here to show. I'll bring that up. 1 2 1 2. Oh, look, the audio's still there. Okay, back to the article. The image you're seeing now on screen, this is a close-up image of the pulsar, shows the X-ray in blue light. So in X-ray, the glow which is blue of the object and the energetic particles around it. The pulsar has recently broken through the bow shock, seen as a semicircle of ionized hydrogen in visible light. So those semicircles you're seeing in red, which is ionized hydrogen as a result of the intense radiation being transmitted by this pulsar. So going on with the article, In fact, the pulsar you're seeing there is PSR J2030 plus 4415. It's a city-sized core that whirls around 3 times every second. It's 1,630 light years away in Cygnus, the Swan. In 2020, Martin de Veris and Roger Romani, both at Stanford University, observed this pulsar using the Chandra X-ray Observatory, in addition to the pulsar itself and the glowing particles around it. They saw a thin straight line of X-ray emission connected to the pulsar. So now I've got another image of that pulsar with that jet that they're talking about. So there it is there. Back to the article. The beam trails off the edge of Discovery image in a celestial version of Harold Purple's crayon, whatever that is. So De Veris and Romani asked Chandra to return the additional observations to determine the beam's true extent, and found that it stretches 15 arc minutes across the sky, or 7 light years long. So that little lot of dots that you see there emanating from a pulsar is actually up to 7 light years long. There is so much energy in that pulsar being transmitted by that pulsar that it stretches that far, 7 light years. It's amazing that a pulsar that only is 10 miles across can create a structure so big that we can see it from thousands of light years away. With the same relative size, if the filament stretched from New York to Los Angeles, the pulsar would be about 100 times smaller than the tiniest object visible to the naked eye, they say here. The team also obtained visible light images using the Gemini telescope on Mauna Kea in Hawaii. The image shows hydrogen alpha light emitted from hydrogen atoms ionized by the pulsar's energy, which was that last image you saw. The pulsar itself is like a bullet that weighs about 1.5 times the mass of the Sun. So Romani explains, so it didn't feel the density increase at all. It caught up to and punched through the stalled bow shock, B-O-W, bow shock, and kept going. The breakthrough briefly aligned the pulsar's own magnetic field lines with those of larger galaxy, allowing a thin thread of particles to escape the pulsar's clutches. Because the breakthrough took place in an astronomical blink of an eye, about 12 years, the researchers estimate the particles are essentially lighting up one of the galaxy's magnetic field lines. This discovery also has broader implications on how electrons and positrons can escape from their apparent pulsars. I'll just come back to me there. Right. Just finishing this article. Events such as this, one might help explain how antimatter can escape and spread through the galaxy. We can already see that the filaments spread with distance from the pulsars, Romani says. Certainly pulsars are a more prosaic explanation for AMS positrons than dark matter annihilation. Granted, observations of such breakthrough events are rare. This is only the 4th pulsar known to have produced a long, narrow filament. But they may be because these events are so brief. They may have occurred throughout our galaxy's history. So we're talking about energetic neutron stars that are producing incredible energy and stretching out vast distances across the universe, and spectrometers on board the International Space Station, the Alpha Magnetic Spectrometer, AMS, is detecting these as positrons. So very interesting physics going on there, all related to astronomy. You're tuned to ASV Radio, VK3EKH, with the regular Friday night broadcast at 20 minutes to 11. Now a little bit of an update on Perseverance, and there's an image here that I'll bring up in a minute, courtesy of astronomy.com. How does one train yourself from having to say now, NASA's Perseverance rover begins to dash Martian Delta, and I'll say that again. NASA's Perseverance rover begins dash, as in running, to Martian Delta. Time has been hard to keep track of these past few years, so it might be surprising to learn that NASA's latest rover, Perseverance, has already been transversing the red planet for some 13 months. Over that span, the rover has racked up a series of impressive firsts. It released the first helicopter to successfully fly on another world. It harvested oxygen from an alien atmosphere for the first time. And it collected and stored samples that will ultimately become the first Mars rocks to be sent back to Earth for further study. So far, all these feats have been achieved without the rover venturing too far from the landing site. But now, Perseverance is finally hightailing it to one of its most tantalizing destinations, an ancient river delta on the rim of Jezero crater, a site that may have once been home to microbial life. The delta is so important that we are actually decided to minimize the science activities and focus on driving to get there more quickly, said Perseverance project scientist Ken Farley in a NASA press release. We'll be taking lots of images of the delta during the drive. The closer we get, the more impressive those images will be, he reckons. Now, I've got a little gift image here of this path that the rover has taken. I'll just pop that up so you can see this thing. Alright, so there it is. It only goes for a few seconds. In fact, I'll just loop that. Loop. Okay, so going to continue. Yep, there it goes. Good. Back to the article. So what you're seeing on your screens, your tube and the TV repeater, is the path that the Perseverance rover is going to take to get to the delta. So the article continues on to say that the fan-shaped delta dates back roughly 3.7 billion years, forming then a Martian river deposited sediment at the mouth of the lake and then exited in Jezero crater. Because deltas experience both flowing liquid water and vigorous mixing, the site is thought to be an ideal location to search for signs of past microbial life. In a 2020 interview with Astronomy magazine, Perseverance Deputy Project Scientist Ken Wilford explained, "That stuff that we find preserved right at the bottom of that beautiful delta in Jezero, that mud, is really fantastic at concentrating and preserving organic matter, and it often does that in a way that's homogenized and jumbled up. It doesn't necessarily preserve those beautiful fossilized structures that you might find at the edge of a lake, but most of the rocks on Earth that are richest in organic matter are rocks that are formed in muddy environments." Perseverance set forth on its 3-mile or 5-kilometre trip to the delta on March 14, and the engineers plan to help self-driving both rover navigate its way there over the course of about a month. Ingenuity leads the way. So now I've got another little image of Ingenuity, the helicopter. I'll see if I can bring that up quickly enough. There it is there. Cut. Audio. Yep, we still got audio. I'll bring up my camera there. And back to the article. Yep, we got it. Righto. So Perseverance won't be alone on its journey, neither. NASA's Ingenuity helicopter will scout ahead of the rover. And what you're seeing on the image there right now is a little gift image of the blades going for a bit of a spin. The Mastcam Z instrument atop Perseverance rover took this video of Ingenuity performing a wiggle test of its carbon fibre blades on April 8, 2021. 11 days before the helicopter became the first self-propelled craft to fly on another world. So that's what you're seeing there. That's just a test of the blade. Ingenuity's original mission was only supposed to include about 5 flights over some 30 days at the beginning of the Perseverance's mission. Now, nearly a year after the rover dropped the rotorcraft on the Martian surface, Ingenuity continues to carry out sorties, S-O-R-T-I-E-S. Oh dear. Just days after its 21st flight, and it's done 21 flights so far. On March 15, NASA extended Ingenuity's mission through September 2022. Ingenuity took its 22nd flight on March 19, which lasted 101.4 seconds, and saw the craft fly 68 meters horizontally and reach an altitude of 10 meters, according to NASA's flight log for Ingenuity. Over the course of its entire mission so far, Ingenuity has travelled more than 4,700 meters, with a total flight time of roughly 40.5 minutes. Despite Ingenuity's impressive track record, it has mostly flown over relatively flat terrain that will change in the next several weeks. The Delta, I don't have it. There's a couple of other images here, but I didn't save them. Anyway, I'll go back to the camera. There we are. Right. So the delta, which spans several miles, rises more than 40 meters above the floor of the Jezero crater, and through the delta has the potential to hold many promising geological insights, possibly including signs of past microbial life. It also harbours many hazards, such as jagged cliffs, askew boulders, and sandy pockets that could halt Perseverance's progress. The Jezero River Delta campaign will be the biggest challenge the Ingenuity team faces since the first flight at Mars, since Teddy Zendendos' Ingenuity team led at NASA's Jet Propulsion Laboratory. To enhance our chances of success, we have increased the size of our team and are making upgrades to our flight software geared toward improving operational flexibility and flight safety, said Teddy Zendendos from the Jet NASA Propulsion Laboratory. That's how that should have gone. Once at the Delta, Ingenuity will scout possible routes or routes Perseverance could take a climb to the top of the Delta. Furthermore, the helicopter's imagery and data will help the rover's team determine possible science targets to more closely investigate with Perseverance's advanced instrument suite and sample collection toolkit. In other words, although Ingenuity may not be vital to the success of Perseverance's main mission, it sure is helpful. Less than a year ago, we didn't even know if powered, controlled flight on an aircraft at Mars was possible, said Thomas Zurbuchen, Associated Administrator for NASA's Science Mission Directorate in NASA's press release. Now, we are looking forward to Ingenuity's improvement in Perseverance's second science campaign, such as transformation of mindset in such a short period of simply amazing, and one of the most historic in animal and one of the most historic in the annals of air and space exploration. Not animals, but annals. Annals. Sometimes these articles are just worded so funny. There. All right. Next article. We've got a little bit more than 10 minutes to 11. G'day, Kim. James Webb Space Telescope. As I do, I try to give an update on the James Webb Telescope, and I've got a picture for that too, for what it's worth. I'll just throw that up. It's a still image of the of some of the mirrors, what the mirrors look like of this telescope in the taken inside the hangar before it went up into space. Oh, the audio's still there. I'm amazed. Oh dear. All right. 1 2 1 2. Yep. Okay. James Webb Space Telescope gets ready to gaze deep into the universe. Powerful new tech and careful planning puts JWST in position to see further than any telescope before March 23rd, 2022. Let's have a little bit of fun with this article. Carrying out the James Webb Space Telescope's JWST groundbreaking mission required powerful technological innovations in optics, detectors, mirrors, and multitude of other areas. JWST's unprecedented scientific power is partly a function of the size and extreme sensitivity of its mirror primary, which collects the images from space. The gold-plated mirror is 21 feet in diameter, giving a collecting area of 273 square feet. At its fully deployed size, the mirror would have been too large to fit into the Ariane 5 rocket that launched it, so it was built in 18 hexagonal segments designed to unfold once the telescope was in space. These segments have to be minutely controlled to meld them into a single optical surface. The JWST has 132 tiny electric motors dedicated to mirror control, and each mirror segment requires 7 smaller motors, 6 to change position and 1 central motor to adjust the radius of the curvature. The reflected light then goes to the secondary mirror, which has another 6 motors to change its position. Because materials change shape as they are cooled, each mirror segment was ground to a shape that was optically wrong at room temperature, but which would warp into correct shape at low operating temperatures of the JWST. After the launch, the mirror segments all pointed in different directions thanks to both tremors during liftoff and thermal contractions caused by a reduction in temperature. To make sure that the segments were properly aligned, NASA chose a particularly bright star in Ursa Major as an alignment target, since it was relatively isolated from other stars and therefore easy to find. The mirrors were then adjusted until they all picked up the image of the star, and the 18 mirrors were merged into one. In the image of the chosen star, it's possible to see tiny shots of light, or tiny spots of light, in the background, each one a distant galaxy millions, if not billions, of light years away and previously out of reach. A taste of JWST's future capabilities. Okay, that sort of brings you up to date. JWST also has a micro-shutter array, a grid of 248,000 doors, which each 0.004 of an inch by 0.008 inch, that can be opened or closed to let in light from a particular object in space while blocking light from other objects. Or the array can select many objects and measure an overall property. To build a telescope that can peer farther than Hubble can, we need a brand new technology. One of the chief engineers of Goddard's Instrument Technology and in the Space Systems Division said in a NASA post about the micro-shutter technology, "We have worked on this design for over 6 years, opening and closing the tiny shutters tens of thousands of times in order to perfect the technology." JWST collects infrared heat radiation, which has a wavelength longer than visible light but shorter than radio waves. Infrared radiation can pass more freely through regions of cosmic gas and dust, and perhaps allow JWST to observe the formation of new planetary systems normally shrouded in fine particles. Infrared radiation travelling from the target object in space is collected by the primary mirror, reflected into the smaller secondary mirror, and then directed into one of the 4 scientific instruments which may focus, filter, or disperse the light. 4 instruments are necessary because some are more suitable than others for observing specific types of objects such as planets, stars, nebula, and galaxies. To keep the infrared glow of the telescope itself from swarming faint astronomical signals, JWST has to operate at extremely low temperatures. One of the instruments needs to be held at a temperature of minus 447 degrees Fahrenheit, a mere 58 degrees above absolute zero. It uses a huge sun shield, 69.5 feet by 46.5 feet, to block heat and light from the sun, earth and moon. Further cooling is provided by a cryo-cooler, a refrigerator based on helium. Control and monitoring of the telescope is carried out by the team of technicians sitting in front of dozens of screens in the high-tech hub at the Space Telescope Science Institute in Baltimore. The link between JWST and the controls is provided by NASA's Deep Space Network. To prepare the team to cope with an unexpected problems, engineers went through dozens of simulations, honing their ability to quickly diagnose and correct malfunctions. We are about to go on this amazing journey of discovery, said astronomer Klaus Potopitin, a Webb project scientist at STS, told Reuters, that company. We really mean discovery, because Webb has the raw power to reveal the unexpected, and we can plan what we think we're going to see, but at the end of the day we know the nature will still surprise us more often than not. Courtesy of astronomy.com, that's under the news tab. Look for the article, James Webb Telescope gets ready to gaze deep into the powerful universe. And it is going to be very, very impressive to see what's going to come from all that in due course. Okay, a few minutes to 11. What do we got here? This is just a short little article. There is another image for this one. I'll finish off with a couple of these short articles. They won't take long to read, thank goodness. Alright, where's the picture? There it is. Bring up the picture. And audio still there, amazingly as it may seem. Alright, what we're looking at there, oh dear. Yes, you're not wrong, Martin. Okay, the question is, what are the differences between supernovae, kilonovae and hypernovae? Briefly, and the image that you're seeing here on the screen, incidentally, astronomers captured this supernova SN 2020 FQV in the act of exploding within the interacting butterfly galaxies. So in that image there, in the middle of that square, you can see there's a square in that galaxy there. They actually catch a supernova exploding. They've actually caught it. Alright, so what are the differences between a supernovae, a kilonovae and a hypernovae? It's probably self-explanatory, really. In Latin, oh no, Latin, I hate Latin. In Latin, nova means new. Well, it's pretty easy. In astronomy, that refers to the temporary bright star in the night sky, but causes of these brief but brilliant stars are varied. Classical novae occur in a binary star system, with a white dwarf and a star close enough together that the white dwarf pulls or accretes material from its companion. The material, mostly hydrogen, sits on the surface of the white dwarf until enough has been gathered to kickstart a nuclear fusion reaction, the same process that powers the sun. As the hydrogen is converted into heavy elements, the temperature increases, which in turn increases the rate of hydrogen burning. At this point, the white dwarf experiences a runaway thermonuclear reaction, ejecting the unburnt hydrogen, which releases 10,000 to 100,000 times energy our sun emits in a year. Because white dwarf remains intact after blowing away its excess, a stellar system can experience multiple classical novae. What's a kilonovae? Kilonovae occur when two compact objects like binary neutron stars or a neutron star and a black hole collide. These mergers, as their name suggests, are about 1,000 times brighter than a classical nova, but not as bright as a supernova, which is 10 to 100 times brighter than a kilonova. There are two basic ways to get a supernova. The type of supernova most people think of is a dying star's last hurrah, known as a type 2 or core collapse supernova. At the end of a massive star's life, it no longer has the energy to support itself against gravity and collapses, the core squeezing itself into a tight ball as possible. The implosion reverberates outward, exploding the leftover material into space. The other type of supernova, a type Ia supernova, occurs when a white dwarf in a binary star system gobbles up too much material from its companion. Unlike with a classical nova, this white dwarf experiences a thermonuclear reaction in its core. Once it crosses a critical mass threshold, it collapses violently, expels its outer layer, tearing itself apart. In both cases, a new stellar remnant, either a neutron star or black hole, is born. A hypernova, sometimes called a collapsar, a collapsar, SAR on the end of that, a collapsar. That's the word, a collapsar. Struth. So, a hypernova, sometimes called a collapsar, is a particularly energetic core collapse supernova. Scientists think a hypernova occurs when stars more than 30 times the mass of the Sun quickly collapse into a black hole. The resulting explosion is 10 to 100 times more powerful than a supernova. There's some mighty explosions that occur in the universe, and thank goodness we are where we are. Alright, one last article before I go to spaceweather.com, and I'll just bring up this beautiful image of this collection of stars, because I did collect this image, and I'll bring it up. 1212, yep, I'm still there. This is ASV Radio, VK3EKH. For those who are up at the dark sky tomorrow night, the Messier Star Party might turn their telescopes to this beautiful collection of stars. It's definitely a must-see cosmic object, the Pleiades. Beautiful to look through in a telescope. Visible to the unaided eye as a tiny congregation of stars due west of Taurus, V-shaped head, the Pleiades M45, Messier object M45, and because we've got the Messier Star Party happening up there tomorrow, I am sure that everybody will be training their telescope on M45, the Pleiades, also known as the Seven Sisters. Is one of the sky's premier open star clusters. Under typical suburban skies, you might be able to count 5 or 6 stars set in the shape of a tiny dipper. Most to move to darker skies though, and that number could double or even triple. One reason the Pleiades puts on such a grand show is because it is only about 445 light years away. That makes it one of the closest clusters to Earth. Just how many stars belong to the Pleiades depends on the source you quote. Some will say about 200, while others will claim more than 1,000. Studies suggest that the Pleiades stars are roughly 100 million years old, mere infants compared to the Sun. The Pleiades spans nearly 2 degrees, making binoculars a wide-field telescopes best for taking in the view. There are several striking binary and multiple stars within M45. The star Atlas, shining at magnitude 3.7, together with Phelion, which varies in brightness from magnitude 4.8 to 5.7, form a wide pair that marks the eastern pointing handle on the shrunken dipper's bow. And Asterope is also a wide pair of stars with wisps of the dust surrounding some of the Pleiades' brightest stars. The brightest portion of the cluster's nebulosity is defined in NGC's 1435 and sits near Merope, the southern eastern star in the Pleiades' bow. That's it. So I think you pull out your binoculars or if you've got a telescope, take it outside and just spend half an hour or so taking in the Pleiades, the Seven Sisters. I think the Seven Sisters was probably one of the first objects I ever really noticed as a kid looking through my pair of binoculars. When they refer to it as the Seven Sisters, you know, you've got to take a look at it, haven't you? Anyway, all right, spaceweather.com. What does spaceweather.com have to say for itself? You're tuned to ASV Radio, VK3 Echo Kilo Hotel, broadcasting on 1865. Looks like we're still on 3541, and by the Melbourne TV repeater, VK3 RTV, and also streaming on YouTube, and also the audio stream. And yes, again, I'd appreciate reports on the audio stream. It is working tonight. We've got the audio stream recovered. I don't know whether the audio, looking at me, I'm into the red on the audio, but we've been transmitting for 2 hours and 53 minutes already. I can see that. But if you want to listen to the audio stream briefly, if you've got Firefox as a browser, I would recommend using Firefox, because the audio stream starts up straight away. But if you've got Chrome as a browser, it will require a right click on your mouse to open up another window when you click on the little icon, which you'll find on the ASV website under the Radio Astronomy tab, and look for the Radio ASV broadcast. Where was I? That's right, I was about to give spaceweather.com a go. Alright, now I've got a picture of the sun here, the latest image of the sun, which is best viewed on the YouTube channel because it's HD. So there it is. Okay. Isn't that a gorgeous object? The source of all life. The solar wind is currently at 441.1 kilometers a second at a density of 5.4 protons per cubic centimeter. The solar disk at the moment, the disk of the sun as we speak, has currently 3 sunspots on it that I can see. Designated, I can't read that number's hard to read. AR 2974, AR 2895, and I think the other one is AR 2970 perhaps. The numbers are on top of each other. But anyway, there's three sunspots on the disk of the sun as we speak. And in HD it looks quite good, but on the standard definition I'm broadcasting through the repeater, it's a bit of a blur. Okay, so the current sunspot number is 44. And the radio sun, sorry, I'm losing my voice. The radio sun is measured at a wavelength of 10.7 centimeters, is 112 solar flux units. And according to spaceweather.com, there is an M-class solar flare earlier today, March 25, at 05:26 UTC. Earth orbiting satellites detected an M1 class solar flare from sunspot AR 2974. The flare caused a minor shortwave radio blackout over Southeast Asia and may have hurtled a CME toward Earth. Confirmation awaits fresh data from SOHO coronagraphs. So there could be more solar activity occurring tomorrow. The thermosphere is heating up. Solar cycle 25 is intensifying, and Earth's upper atmosphere is responding. The thermosphere climate index, TCI, is going up rapidly right now as we speak. Reports Linda Hunt of Science, System and Applications. It has nearly tripled in the past year, she says. This is the Thermosphere Climate Index, TCI. It has tripled in the past year. TCI is a number published daily by NASA which tells us how hot Earth's upper atmosphere is. The thermosphere, our atmosphere's highest layer, literally touches space and is a sort of first responder to solar activity. Hunt created this plot showing how TCI has unfolded during the last 7 solar cycles. Solar cycle 25 is getting started. Now I didn't take a picture of the chart here, but if you go to the spaceweather.com website, you'll see the graph that's depicting this increase in the TCI figure. So far solar cycle 25 is well ahead of the pace for solar cycle 24, notes Hunt. If this trend continues, the thermosphere could soon hit a 20-year high in temperature. Before we go any further, a word of caution, they say here. This does not mean Earth is about to heat up. Stress underline apostrophe marks. The thermosphere is hundreds of kilometers above our heads. Here on the planet's surface we do not feel its heat. Summer days are no warmer than TCI is hot. As Dr. Marty of NASA notes, energy driving the climate system near Earth's surface is hundreds of thousands of times greater than in the thermosphere. As far as we know, cyclical warming and cooling of the thermosphere by a solar cycle does not affect Earth's climate as such. Nevertheless, the thermosphere is important. When it heats up as it's doing right now, it also puffs up. Think of a marshmallow held over a campfire. Yes, I think we've all done that. The thermosphere can expand upward to so much it actually touches Earth's orbiting satellites. Almost 40 Starlink satellites fell out of the sky earlier this year as a result of aerodynamic drag up there. So there you go. Anyway, enough of that. So, alright, finishing off. Potentially hazardous asteroids are space rocks larger than approximately 100 meters. As of the 25th of March 2022, there are 2,271 potentially hazardous asteroids. Alright, and looking at the Antarctica for the Aurora, there is a little bit of auroral activity occurring. It's kind of a 50-50 thing if you're likely to see it, but it is off the coast of Tasmania, probably a little bit too far south. So even if you're on the coast of southern tip of Tasmania, you might just see a glow in the southern sky. But otherwise, it's nothing much to mention really, even though I did. All right. At 13 minutes past the hour, I filled up an hour because of the stuff up at the beginning. I've had to make it up, haven't I? All right, so we've had emails from Andrew and Don and Simon, who reports that the BATC stream was up and running, and Ian also has an email. I'm using the wrong mouse here. Also has an email, and he reports that hi Clint, thank you for a most interesting broadcast. Yeah, well, we struggled at the start there, but yeah, thanks for that. 160 broadcast is 5657 and quite clear. You see, I'm broadcasting AM on 160 tonight. It's 100 watts on 1865, so it's interesting to see how good the AM signal is getting out. I was that close to thinking about running AM on 80 meters tonight, and I could still do that, but I've just got to do some shielding. I'll get a bit of RF into some of these audio cables hanging around here. That was the problem I had earlier on. All right. So thanks for everybody who's come in on Discord. Kim, VK5FUSE, Martin, VK7JH. Richard was there too, Mr. VRS. I can't see Tony. And who else was there on Mike? Oh, Mr. Mike was there, Mr. XL. You need to get some mothballs, I think. Oh. All right. You know, at about 10 seconds to 10 o'clock, I was actually going over to my wardrobe to look for a better T-shirt, and I thought, stuff it. All right. Oh, look, Tony is there. No, he's getting there. He says Tony is logged in. Oh, where is he, though? I can't see him. Where are you, Tony? I can't see you logged in on VRS. I mean, on the Discord. All right, enough of this. I'm going to finish. We're going to go off on 80 meters. Sorry, 160. So for those stations listening on 160 AM tonight, I would appreciate a report from you guys. I'm sure the signal is going far and wide, but we decided to run amplitude modulation tonight, one of my favourite modes. But just because the audio sounded so much cleaner, and when I put the headphones on, so yeah. So VK3EKH@gmail.com. Just send us a report. VK3EKH, VK3 Echo Kilo Hotel @gmail.com. Simple. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. I apologise for the stuffed up start to the broadcast today, but that's nothing unusual really. So we're concluding our medium wave service and restoring the frequency back to band noise. And we shall be back again next week. More information about the Astronomical Society of Victoria can be found on the ASV website at www.asv.org.au. Yes, this is VK3EKH with VK3CSJ on the microphone, concluding transmissions on 1865 and bidding all listeners here a very pleasant good evening. So that's 160 off, much to the valves and the linear's relief. All right. All right, now if everything else is okay, we shall find a pen, and we shall. In fact, I now have the audio output from the receiver on 80 meters via the mixer, so I can now directly feed an audio level. Hopefully, that's going to work. An audio level direct from 80 meters over the TV and YouTube and the sound stream, instead of being picked up by the microphone. And I might also add that tonight's broadcast has been done on one microphone. Normally I have the internal microphone in the camera here working. I've removed that. There's no audio running off the microphone, so when I do this, it shouldn't come through, hopefully. But if I do this, that's that's the microphone I'm using live to where it's a Heil a Heil PR40 microphone, super high quality studio quality microphone, some say, and there it is. That's what I've been using tonight for all audio everywhere. Okay, where was I? Okay, this is VK3EKH taking a quick listen on got the headphones in. I wouldn't have heard you with the headphones plugged in. And make sure I've got the audio up. So this is VK3EKH listening on 3541 kHz for any stations wishing to check in.
VK3VIN. VK3HDX. VK3KHD.
Alright, VK3VIN, VK3HDX and VK3KKG, I think it was. Was that right? Is that Kilo Golf?
Correction, that was VK3 Kilo Hotel Tango. Bill at Upper Point.
Thanks, Bill. Got it that time. VK3 Hotel Golf. Hey, Kilo Hotel Golf. Sorry about that. Thanks, Bill. Any other stations wishing to check in? VK3EKH? Alright, VK1TTY and VK3BTV. Any other stations? Or weaker signal there, VK3, say again? All right, we've got VK7 Julia Hotel there, Julia Alpha Hotel. G'day, Martin. Yeah, the VK3 station just a little bit weak. Just repeat your call sign again, please.
VK3 Tango Sierra Mike.
All right, I think that was a stronger signal. Tango Sierra Mike. All right, we'll come to you in a minute. All right, let's pick it up. Ian, VK3VIN. How are you? VK3HD. Oh my goodness me. VK3EKH.
Well, that sort of that verifies what I've been thinking. VK3EKH, VK3VIN. You're sounding a little distracted tonight, Clint, but a good broadcast. By the way, there's a VK5 trying to check in as well. I can just hear him in the background.
It's probably Kim.
Yeah, good broadcast. Very complex, involved, and obviously the whatever the issues were at the start, I missed the first 15 minutes or so.
Oh, you missed the good part.
20 minutes for the broadcast. But picked it up just as I think you went into the first article. So, but a really good general broadcast. Nothing specific to comment on. And I think maybe all the images might have distracted me too. So the words and the images, because I was missing out on the images, the words weren't quite clicking as they would normally. Plus the fact that we had rather slow QSB, very slow and gentle and deep. And as I mentioned in my email, the signal was down. The actual signal itself was down, so maybe we're under the influence of a solar flare or something similar, as reported in space weather. However, as always, I enjoyed the broadcast, and thanks for taking the time to read it. VK3EKH, VK3VIN.
Yeah, thanks, Ian. VK3VIN. VK3EKH returning, and yeah, well, you didn't miss much. The first 10 to 12 minutes I was seriously having problems with audio. Most of the problem was RF getting into some of the audio leads I've got flying around here, so that was the most problem. I turned off the linear. So I was only running 100 watts tonight on 80 meters, so only barefoot, as they say. So if you think you're getting a slightly weaker signal from me compared to last week, that's why. But I'll have to investigate the setup here a bit more and try and get it all sussed out for next week, hopefully. Anyway, thanks, Ian, and yeah, yes, I had a lot of images there to show, but I think the images flowed reasonably well with the articles I had going. They were all kind of in sequence the way I do it. So yeah, but yeah, no, thanks, Ian. Good to hear you, and you're 5 and 9 plus about, let's say, about 15 over thereabouts. Across to you, Don. VK3HDX, VK3EKH.
VK3EKH in the group, VK3HDX. G'day Clint, g'day everyone. Good broadcast. Don't worry about the beginning. That was part of the entertainment. It was good being able to watch you try and sort it out as well. No, great broadcast. Enjoyed all the pictures, and I sat back and listened to it on 160 on AM. Through the audio amp and the hi-fi speakers, and it sounded fantastic, Clint. I really enjoyed it. Thanks for your efforts once again, and we'll look forward to next week. VK3EKH in the group, VK3HDX.
Thanks, Don. VK3HDX, VK3EKH. Very good. You're about 20 over. Signals are a little bit down tonight, I can see, but nevertheless, thanks for the report. And you know, I might stick to running AM on 160. So it just for the sake of it. I have run AM once on, or maybe twice, but at least I have run AM once on 80 meters, and I think it was reasonably accepted. Everybody was reaching for their, where's our AM mode on their transceivers, and never used AM. Some didn't even realise they had AM on their transceiver. Those were the days. Thanks, Dom. All right, Bill, VK3 Kilo Hotel Golf, VK3KHG, VK3EKH.
VK3EKH, VK3 Kilo Hotel Tango. A good program tonight. The lead-in was worth watching. It's nice to see that things don't go perfectly for other people at times. But good signal on 80 metres, and the video was good tonight. Where I am, it's not always good, but it is tonight. That's about all. Enjoying the hobby, and your program is part of it. Okay. Greetings to the group, and I'll pass it back now. This is VK3 Kilo Hotel Tango, passing it back to VK3 EKH.
Thanks, Bill. VK3 Kilo Hotel Tango. Sorry about the mix-up on the call sign. Sometimes I when I'm writing call signs down, I go over it, over my writing 2-3 times, and that's it. It's stuffed. I can't read it. So I've rewritten your call sign nice and clearly now. Yeah, thanks, Bill. VK3KHT, VK3EKH. Very good. And thanks for also watching as well. So it makes it all worthwhile, as I say every week. Hopefully, yeah, next week will be trouble-free. Thanks, Bill. Tim, I think it is, VK1 Tango Tango Yankee, VK1 TTY, VK3EKH.
VK3EKH, good afternoon there, Clint. VK1 Tango Tango Yankee. Thank you very much for the broadcast there, mate. I was listening on 160, and it was absolutely superb down here. It was solid 5 and 7 the whole night, and I was listening on the patch through on my Behringer mixer and with the hi-fi headphones on, so it was very, very relaxing. I'm currently sitting on a nice rum at the moment, but the broadcast was very nice to go with it, and yeah, thank you very much for that. Just a quick question for you, mate. How are you feeding the radios there with the mixer here going in through the accessory port, or are you coming through the mic port? Oh, and there goes my internet. Oh goodness me! I've got to love VDSL. VK3 EKH, VK1 TTY.
Yeah, thanks, Tim. VK1 TTY, VK3 EKH returning. Well, it's a bit of a minefield. About a week ago, it's a Behringer. It's a 16-channel Behringer mixer. It's an X-ray 2222. Yep, just checking on that. An X-ray 2222, 2222. That's better. So it's an X-ray 2222 USB. And I've had this Behringer mixer for quite a while. It's been part of the shack. It's sort of been in and out of the shack over the years, but I've reintroduced it more or less, and I wanted to explore the USB side of it because I knew that there was it was possible to communicate or use the USB connection. Now, about a week ago, we mucked around with that, and we did manage to get the USB port working. Actually, it works straight away. As soon as you plug the mixer into a USB port, it actually detects it straight away. And the computer here came up with another input. It didn't say Behringer. It just said that it was seeing another digital input. So, well, with a bit of mucking around, it actually worked. And I thought, oh, well, there you go. But what I haven't been able to get working, and this is, if I can suss this out, it might make things a bit easier here. But if I can suss out sending audio from the computer to the mixer, then I can feed audio over HF. But I stuffed around with that today a little bit more, and I couldn't quite get that to work. And I was just heading into a troubled spot. So I went down and had some lunch and cooled off a bit. And I thought the only way I'm going to be able to get this sussed out quickly for tonight anyway is to use the line input. So all the audio at this stage is going in via the standard analog line input on the back of the computer. And but I run vMix. I also run vMix on the computer here for passing all the vision and the audio, the other part of the station, the digital stuff, to the TV system, and that via the computer. But from the from the HF station here, the two HF radios, I use the analog side of it. So I just need to tidy that up a little bit, and hopefully if we can use the USB connection, that should tidy things up a bit more. I can get rid of a few other cables that are lying around, and hopefully that won't have any problems with RF from that point onwards, but we'll need to explore that one a bit more. Okay, thanks Tim. Now Kieran, just give me a couple of minutes before I come across to you. I've just got to quickly go downstairs. It's just a quick second job here, and I'll be with you in just a second or two. VK3 BTV to take it in a minute. Just hang on, Kieran. VK3 EKH. Oh, sorry about that. It was such situation downstairs with the television. Sorry, Karen. VK3BTV, VK3EKH.
VK3BTV. My signal's not going to be too strong to you tonight because I'm running a little bit of a handicapped antenna, but we'll fix that up shortly. Love the broadcast tonight, and one of my pet faves is Ingenuity, nicknamed Jenny, which is that helicopter in the Earth Mars that cost $80 million. It's 1.8 kilos and it's about the size of a pressure cooker. And yeah, amazing stuff. It's not a drone. It's autonomous because the commands to it take 5 to 20 minutes to transmit. But I think that's one of the most one of the greatest human achievements so far in engineering anyway. And I do like that F-hole acoustic guitar you got there in the background. I've got 4 guitars here, but I don't have one like that. VK3BTV.
VK3BTV. VK3, lovely call sign that, VK3BTV. I've mentioned that before. VK3BTV, VK3EKH, VK3CSJ on the microphone. Yeah, thanks, Kieran. And yeah, the complexity that we give ourselves in our life is an amazing thing. But somehow we manage with modern technologies. And I could really make this shack quite simple in its operation, but when I first started doing this broadcast on Friday nights, I just did it on 80 meters, and how easy is that? No video to worry about. I just had the hi-fi microphone set up on 80 meters, and away it went. But I decided to include the Melbourne TV repeater, and I thought, why not run YouTube and then the audio streaming for those who got sick and tired of listening to the band noise. And yeah, it just became a bit complex, but can be done. Anyway, that's another story. Thanks, Kieran. And yeah, the guitar behind me it's actually not mine, belongs to my cousin, but he gave that to me probably about 30 years ago, and he's probably forgotten about it. So I've just very carefully looked after it all these years. During the 80s, I is when I learned a few chords and made a few tunes. But otherwise, it's getting dusty at this stage, and the action between the strings and the fretboard is a little bit on the tough side for fingers that don't. You know, if you haven't played guitar, your fingertips aren't really good for applying decent pressure. And of course, a true guitarist will have virtually no fingernails. Or his plucking hand will have fingernails, but his finger for creating chords will be no fingernails, because he bites them until they're all little nubs on their fingers. I don't have that. I've never been one for biting my nails. So when it comes to playing the guitar, I've got to deal with the neighbouring strings hitting my fingernails, and it just becomes painful after a while. But I learned a few chords, and surprisingly enough, I still remember them. And I actually picked up the guitar a few weeks ago to put it in shot just as something different, but it was so dusty. But I tuned it up. I'm sure, I don't know if you're actually watching any of the video side of this, but that's the tuner that I used. I've just got that on TV right now. Little Korg guitar tuner, which works very well. And I tuned the guitar up. Actually wasn't too far. It was out of tune. Yep, but it wasn't that far out. So anyway, it's producing a nice sound now. My fingernails have got long again, so I won't do it. not on air. Anyway, thanks, Kieran. VK3 TSM, I think it was. VK3 Tilo. VK3 Tango Sierra Mike, if I got that right, correct call sign. VK3 EKH listening. Maybe he's gone. I'll go across to you there, Martin. VK7JAH, you still there? VK3 EKH. Yeah, thanks, Martin. Well, let's just hope that next week goes a little bit more professional, and I'll make sure that I put on a better t-shirt. Maybe I'll put up a green screen as well, so to hide all this radio stuff and the guitar behind me, and do something quite professional. Actually, if I put up the green screen, that's just going to bring in another level of complexity, which will throw me. But I'll worry about that as soon as I get my audio part of the station sussed out. I'll think about the green screen. But anyway, Martin, thanks very much. You're basically 5 and 9. Not very strong, but we can hear you. Anyway, I'll take one more listen on the frequency if there's any other stations wishing to check in. VK3 EKH. Gee, that's a weak signal, Tony. Go ahead. Oh, you're just checking in. Do you want to say anything? VK3 VAT. VK3 EKH.
Yeah, no worries. I'm just doing 5 watts on that random wire, so just playing around. But you can hear me, I guess. Yeah, interesting session tonight to start with, wasn't it?
I don't want to think about it. Yeah, it was just a last-minute thing to rearrange the audio side of the station. As Richard mentioned before, earlier in the week, we kind of mucked around with the audio side of things, and we thought we had it right. And some of the tests I did a few hours earlier on today, everything looked all right. But mind you, I didn't have the linears on. I should have turned both linear amplifiers on just to make sure that there wasn't going to be any RF issues, and there was. So that was our, I think, our Achilles heel tonight. And anyway, I'll muck around with that because I've got audio leads everywhere here, and it really is annoying me. So I must try and tidy things up a bit. Anyway, alright, if there's no other stations, we'll conclude our service tonight and let things cool down. So VK3 EKH, just taking one more quick listen on 80 metres.
There was absolutely nothing to worry about with the audio quality on 80 metres. Clint, was just the signal strength was down a little bit, and you've explained that with the barefoot power. So nothing to worry about. VK3VIN.
Yeah, no worries, Ian. Let's just see if this is going to work. It might not, but I'll turn the linear on. It's actually in standby, so just a sec. Oh no, I did. I turned it off completely. All right, no, I won't worry about it. It's got valves in it, so I won't worry about it. But I thought I left it in standby, but no, there it is. All right, we'll make sure next week's fine. Alright, on that basis, this is VK3 EKH, the official station of the Astronomical Society of Victoria. If there's anybody listening up at Heathcote on the shortwave receivers up there, I wish you all a very great star party tomorrow. I'm sorry that I can't make it due to a variety of little reasons. One is the cost of petrol. It takes $50 at the moment to fill up half a tank. And secondly, the temperature. My problem with the engine is still there. I don't know what it is, but I've noticed that even just driving around town, the temperature gauge starts to go high. So I've still got a temperature issue, and I don't want to get halfway between Melbourne, between here and Heathcote with problems with the car. And I don't know, there was some other excuse. I can't remember now, but anyway, I wish everybody up there at the Star Party a great time. Enjoy yourselves, look at the sky, that's what it's all about, and have a good time. And to the folks that are manning the radio astronomy section laboratory, Phil Costigan and Stephen Bentley, have a good time, and entertain the crowds, which should be interesting. Alright, this is VK3 EKH on behalf of the Astronomical Society of Victoria, concluding transmissions on 3541 kHz, and we'll be back next week to do it all again, but hopefully without the problems. So we'll see how we go. This is VK3 EKH with VK3 CSJ on the microphone, concluding transmissions. Bye everyone.
Thanks, Clint. Have a good night. Bye-bye.
Okay, let's kill this audio stream. I don't know if anybody's been looking at the audio stream. Just take that down. So this is ASV radio. 3 hours and 34 minutes of audio stream. Amazing. Anyway, we'll kill the audio stream, and hopefully there's been someone out there that's listened and given me a report on the audio stream. So we'll just kill that, and we'll be back next week to do it all again. This is ASV radio. Alright, so we've got that, and now the YouTube stream. Alright, so anybody who's been watching YouTube, thanks for watching the HD side of the station. Anybody overseas that have been watching, I appreciate sending comments like everybody does. Write a comment in the comments section. VK3EKH@gmail.com is good enough. VK3EKH@gmail.com. Send us an email if you are overseas and watching. Joe in South Korea, maybe you're watching. I don't know, maybe somebody else out there. What else? No, I think that's about it. I'm out of here. So I shall kill the stream before I run out of internet time, because I have forgotten to pay my bill and it's doubled up on me. So I'm getting notifications from Telstra saying that they're going to slow the system down if I don't do something about that, so I better stop my stream before I run out of... Oh, it's actually unlimited, so it shouldn't be a problem really. Anyway, this is ASV Radio under the call sign, radio call sign VK3EKH. On behalf of the Astronomical Society of Victoria, we're finishing our stream. So until next Friday. Oh, actually, no, I'll be back streaming. I forgot to mention. No, I'm still on the repeater here. The WIA broadcast this Sunday morning at 10:30. I will be doing the WIA broadcast on behalf of the Wireless Institute of Australia, but also it's the video representation by Brendan, VK5BD. That's 10:30, and repeated again at 8 o'clock on Sunday night, if all goes well. And then of course the Tuesday night ATV net at 8 o'clock on the repeater. Don't forget that one too. I missed it last Tuesday myself. So that's enough for the advertising, and thanks for watching. Alright, I'm I've got my mouse on the stop streaming button where it says yes, stop the stream. So I'm going to count down 5, 4, 3, 2, 1.